I've recorded this PowerPoint presentation to help you with question 1 of the LV02.2 K written assessment. So let's focus in on the first part of the question. What you've got to do is to describe the operation of a typical exhaust gas recirculation system fitted to a light vehicle engine, and that's worth 10 marks. Now, to be able to do this, we need to have an understanding of the combustion process inside an engine. So I'm going to consider the inputs to an engine, i.e. the fuel inputs, and compare those to the outputs, or what comes out of the exhaust pipe. Now, all fossil fuels, so that's petrol, diesel, gas, etc., are a form of hydrocarbon, and in order to burn any fuel actually, we need to mix the fuel with air. And air is made up of oxygen, and the other main component part of our air is nitrogen. There are a few other bits and pieces, but these are the main component parts. So let's just label those up. So we've got hydrocarbon is our fuel, and oxygen and nitrogen are our air. Now, what the combustion process does is it takes the hydrogen from the hydrocarbon and oxidizes it. And that process forms H2O. The hydrogen is oxidized with the oxygen and produces H2O, which we know as water. Now, the carbon that's in our fuel, in the hydrocarbon, is also oxidized, and that forms carbon dioxide. And these two things are relatively harmless. Water is obviously very harmless. Carbon dioxide is what we breathe out as humans. That's what we breathe out. And then the plants and trees take on the CO2, the carbon dioxide, and they strip it down, and they use the carbon to produce plant fibers or wood, and they give off the oxygen, which we in turn then breathe back in again. So if we have good, clean combustion, this is what we should produce. Now, the nitrogen that's in our air is considered to be an inert gas. And inert means it doesn't react. So if we have a decent, clean burn mixture, the nitrogen will go into our engine and comes out of the exhaust unchanged. It hasn't reacted. And this only happens if we have an ideal mixture of fuel and air. And the ideal air-fuel ratio is 14.7 to 1. So that's 14.7 grams of air for every 1 gram of fuel, or petrol in this case. Now, if we run on a slightly weaker mixture, so less fuel or more air, let's put some more air in. I'm going to put this in at 16 to 1. So that's 16 grams of air to 1 gram of fuel. Now, that fuel mixture won't burn as cleanly, but it will actually burn much hotter, produce a lot more heat. And more heat means more power. So we can produce more power, but the problem is that because it's so hot, what happens is our nitrogen oxidizes, and we produce various oxides of nitrogen. And oxides of nitrogen do two things. One is they contribute to climate change by creating a greenhouse effect. And the second thing is that the oxides of nitrogen are harmful to human lungs and clog up our lungs, make it difficult for us to breathe. Okay, so what we need to do is to reduce the amount of nitrogen oxides or oxides of nitrogen that we produce, but in an ideal world we'd like to run on a slightly weaker mixture to produce more power. And that's what the EGR valve does. I've just noticed on this diagram that it's labelled up as ERG. That should say EGR, Exhaust Gas Recirculation Valve. Now, here we've got a diagram of an engine, and the intake manifold is allowing the air to flow in, and that would obviously be mixed with petrol, and that flows into our engine, and we go through the 4-stroke cycle and combust the fuel and air. And then at the end of that, the last stroke is the exhaust stroke. Once we've extracted all the energy from the petrol, it's now exhausted, and we push it out through the exhaust pipe. Now, what the EGR valve does is it allows some of that exhaust gas to be recycled, if you like, and returned back to the inlet side, which then means that it's drawn back into the engine. And obviously, once it's been burnt once, it can't burn again. So what that does is it reduces the combustion temperature and therefore prevents those oxides of nitrogen from being formed. Okay, I'm going to send you some links to some other YouTube videos and other information that I think might be useful, but you should now be able to answer that first question, first part A of the question.